Okay, the title of this page is Proving Lines Parallel. So on this, we're going to go over a little bit of what parallel means. Parallel means lines that never intersect or touch and have the same slope, which is very important. An example of parallel lines could just be two straight lines that look like this, and they're going to have the same exact slope. They're going to rise and fall at the same rate. The symbol for parallel, if I had labeled this line A and this line B, we would say A, two lines, looks like two L's, is parallel to B. Okay? So when we're proving lines parallel, there are four angle pair relationships. The first one is alternate exterior. Next one is alternate interior. The third is corresponding. And the last type is consecutive interior. Okay, and these are all angle pairs. And I'm going to go over an example of what these look like in a second. So your alternate exterior angles are congruent. Your alternate interior angles are congruent. And your corresponding angles are congruent. The only type that is not congruent is consecutive interior. These are your special types. These are going to be supplementary, which, as we learned before, means adds up to 180 degrees. Okay, so we're going to do a quick example with this. So in order to give you an example, what you want to do is you want to draw two parallel lines and then go ahead and draw a transversal through it, which is just a straight line that's going to intersect both of those lines. We're going to label this 1, 2, 3, 4, 5, 6, 7, and 8. An example of alternate exterior angles is going to be angles that are on opposite sides and on the outside. Okay, the outside is going to be anything on this region. The inside is anything in this region. So an example of alternate exterior angles would be 2 and 8. And the other pair would be 1 and 7. Alright, an example of, and I'll label this for you, alternate exterior. An example of alternate interior angles is going to be on opposite sides, but they're going to be on the interior. So it would be something like 3 and 6, opposite sides, or 4 and 5. Alright. An example of your corresponding, there's many types of corresponding angles in any example, would be, I'll give you one, we could choose 1 and 6. Those would be corresponding to each other. And I'll explain why in a second. The reason why is because corresponding have to be on the same side. So I could cover up this side, have to be on the same side. They also have to be in the same relationship to these two parallel lines. See how they are above the line? Above the line? That's why they're corresponding. So similar to that, if you know that, what would the other pair be? The other pair would be on the same side, and it would be below. So it would be angle 4 and angle 8. Okay, cover up the other side if you want to find the other two pair. So same side but above the line. So angle 2 and angle 5, both above. Write that down. And the other pair would be below. So angle 3 and angle 7. Right? And our last type is our consecutive interior. Consecutive means that they're going to be next to each other or same side. And interior means they're on this interior region. Okay, so an example would be angle 3 and angle 5. Consecutive interior. Okay, so you do the same trick where you want to cover it up because they're both consecutive on the same side, and it has to be in that middle inside region. So that's why it'd be 3 and 5. And just a reminder, these two are the only type that are going to add up to 180. So I'll go ahead and write that down. Angle 3 and angle 5. Go ahead and do the trick. Cover up one side. You want consecutive, meaning same side, and you want interior, so you want 4 and 6. Consecutive interior, 4 and 6. Okay? And those are your 4 angle pairs that prove lines parallel.